Today we will be solving Mathematics, Probability and Statistics 1, May June 2018, Paper 6, Variant 1. In a statistics lesson, 12 people were asked to think of a number x between 1 and 2 inclusive. From the results, Tom found and that the standard deviation of x is 4.5. Assuming that Tom's calculations are correct, find the values of summation x minus 10 and summation x minus 10 squared. Firstly, let's write all the information that has been given to us collectively so that it's easier to work out. So the number is given, and then summation x is given, which is 186, and standard deviation of x is also given as 4.5. Also, summation of x minus 10 and summation of x minus 10 squared is to be found out. So firstly, let's work out the mean of x. We have this formula, summation of x over number is equals to mean of x. Using this, we can put in the values, which are 186 over 12, and that would give us an answer of 15.5. So our mean of x is 15.5. Now let's build in another equation, which is taking this here. Let's say mean of y is equals to mean of x minus 10. So we know this mean of x, so we can put in the equation to find out. (15.5) minus 10, and mean of y will be 5.5. Now using this mean of y, we can again find out summation of this thing right here, since we made this equation. Right, so that would be again this formula, summation of y over n is equals to mean of y. Summation of y is unknown. N is 12 into mean of y is 5.5, and the answer would be 66. So now we know that this right here is equals to 66. Now we need to find this. Now we can use this information right here, that the standard deviation of x is 4.5. So one thing we know for sure is that standard deviation of x is equal to standard deviation of y. So using the standard deviation, which is 4.5, let us write the formula first. The formula would be standard deviation of y equals to summation of y square over n minus mean of y the whole square, and this under root. So this is the formula. Now putting in the values, we can write the standard deviation, which is 4.5, as it is given right here in the question. And we can put in a square to shift this square under root, and we don't know summation y square. We know the number, and we know the mean. Mean is, we just found it out, which was this 5.5 right here. So putting back 5.5 squared, and this calculation would give you an answer of summation square 606. This is how we know that summation of x minus 10 squared is 606. That's it for question 1. Moving on to question 2. In a survey, 55 students were asked to record to the nearest kilometer the number of kilometers they traveled to school in a particular week. The results are shown below. On the grid, draw a pause and whisker plot to illustrate this data. So we know that for a box and whisker plot, which things are necessary. First is median. Second is the lower quartile number, lower quartile, and obviously these least and highest values as well. So we already know these highest and least values, so we need to find these three. So what would they be? Let's figure out. So how can we find the mean of this whole? We know that there are 55 students, and we know that there is a formula for, sorry, not mean, median actually. I've been saying it wrong. So we need to find median, and we know the formula is n plus 1 over 2. And here is what? It's 55. So 55 plus 1 over 2, and that's 28 number. So let's count and see whether the 28th number would be. So the 20th value is right here, which is our 25. Let me just underline it. So this is the median, 25. Let's find out the lower quartile. Basically what we have to do for the lower quartile is just the same thing, which is finding the median of this area. So that would be again by this formula, n plus 1 over 2, but this time we will use the n as 28 plus 1 over 2. This will be 14.5. So we have to see 14.5th value, which would be between these two. These are 14 and 15. These are both 18, so the lower quartile is just going to be 18. Now the same procedure for the upper quartile. These are 14, 15 values are these, and their mean is obviously 50. So we have found out all the three necessary values that we need to draw a box and whisker plot. So let's now make it. Label the axis. We know that this is distance in kilometers. So write it here, distance kilometer. I'm just going to draw a rough diagram. You should use a ruler and pencil, sharpened pencil, to draw the plot. This is my scale. Now we just have to find the values. The least value is 5. So we are going to first plot that right here. And again. Now our lower quartile, which is 18. 18 should be here. Then median is 25. So 25. Please be accurate with your points. And upper quartile 50, and then 70. 50. And lastly 70. So these are all the points. Now join them. Make sure that you first draw the boxes of lower quartile, median, and upper quartile. And this is our plot. Show that there are no outliers. First we need to read what an outlier is. An outlier is defined as any data value which is more than 1.5 times the interquartile range above the upper quartile, or more than 1.5 times the interquartile range below the lower quartile. So we need to do some calculations first. So let's find out the interquartile range first, because that's the thing which we don't have right now. We have upper quartile, lower quartile, but we don't have interquartile range. So let's find that out. Interquartile range. You need to remember what an interquartile range is. It's simply the subtraction between upper quartile and lower quartile. Since we have already found out both the upper and lower quartiles, which were 50 and 18, so we can easily find it out. It's 32. Now with this saying that more than 1.5 times interquartile above the upper quartile. So let's check. 1.5 times the interquartile range is what? It's 48. So now we just need to see by subtracting and adding. Let's first do the upper quartile one. Let's add 48 to upper quartile upper quartile was 50, I believe. Yes, it's 50. So 50 plus 48 is 98. For lower quartile, 18 minus 48. That will be an answer that would be negative, and it's negative 30. So now we need to see if any of the values are like this. There are none. There is no minus 30 or 98. So no outliers. Andy has 4 red socks and 8 black socks in his drawer. He takes 2 socks at random from his drawer. Find the probability that the socks taken are of different colors. For this, let's set up a tree diagram first. So when he picks up, it can either be a red sock or a black sock. And it is written here that he took 2 socks. So that means we have to repeat this cycle 2 times. So this is 1 time, first time, and again it would either be red or black. And if it's this case, then either red or black. And this is the second time. Now find the probability that the socks taken are of different colors. So let's first put in the probabilities on this diagram. So for red, what is the probability? The total number of socks is 12. So red's probability would be 4 over 12. Since there are 4 red socks and the total number of socks is 12, which is 4 plus 8, what would be the probability of picking a black on the first attempt? And that would be 8 over 12. Moving to the red sock on the second time, the probability would decrease from 4 to 3 since there are only 3 socks left. After picking one, so it's 3, and the total number is also decreased to 11. For black sock, since no black socks were taken out here, so the number of black socks is retained, which is 8 over 11. Coming on to the other part, since the black sock was taken out, so red's number would be retained, which is 4 over 11, and the black would be 7 over 11. Now they're asking for the probability of taking out 2 different colors, so that would be this one and this one. Let's write it down. Forming an equation. The first one, red, which is 4 over 11 into, remember when they belong to the same branch, this is the same branch, they would always be multiplied. So 4 over 12 into 8 over 11 plus, and when you are calculating probability for 2 different branches, then they would be added, right? So black 8 over 12 and red 4 over 11. And the answer is 0.485. Make sure to give in 3 significant figures. The random variable x is the number of red socks taken. Okay, draw up the probability distribution table for x. So this is now from the chapter discrete random variable. Now we need to set up a probability distribution table. So let's think about one thing, that what is the total number of socks that could be taken? Obviously there are 4 red socks, then obviously we can only either get a 0 red sock, 1 or 2 red socks, 3 or 4. There could be no more than this. So this sets up the table for us. Let's draw the table first. Well, actually, these things 3 and 4 are wrong. Since he was only taking out the socks 2 times, then we would only consider the probability of getting a red sock 2 times, right? So let's write this down. 2 times. So that could only be either a 0 red sock comes up, like shown in this diagram, where a black and black sock is getting out. So either a 0 red sock is taken out, either 1 or 2. So 3 and 4 are not an option, so we're going to erase this. Now for the table. This part shows number of red socks, and this part is the probability part, and there would only be 3 columns. So either 0 red sock is taken, 1, 2. Now let's find the probability, which is very easy. You'll just have to use this tree diagram that you made earlier. For 0 red socks, let me show you this, and this probability will be used since both black socks were taken. So for both black, 8 over 12 and 7 over 12, you just have to multiply 8 over 12. Probability of 0 red socks, 8 over 12 into 7 over 11, which is 14 over 33. Probability of 1 red sock, that would be what we found out earlier. Since there was just 1 red sock in each of the probability that we found out, so this probability was equal to 16 over 33. So the answer here would be 16 over 33. And then for 2 red socks, let's just use this space. 2 red socks, it is from the diagram this and this, which is 4 over 12 and 3 over 11. 4 over 12 and 3 over 11, and the answer would be 3 over 33. Moving on, find EX. This would just be the summation of number of socks and their probabilities. So it would be summation of all the number of red socks into their probabilities, meaning 0 into 14 over 33, which would be 0, plus 1 over 16 over 3, which would be 16 over 33, plus 2 into 3 over 33, which would be 6 over 33. And doing the calculation, you'll get an answer of 2 over 3. That's the answer. Now, the distance that car tires of a certain make can travel before they need to be replaced has a normal distribution. A survey of a large number of these tires found that the probability of this distance being more than 36,800 km is 0.0082, and the probability of this distance being more than 31,000 km is this. Find the mean and standard deviation of the distribution. So, the mean and standard deviation. So that first, since 2 types of information has been given to us, let's write it in the language of normal distribution. So being more than, so these 2 equations show the information that has been given to us. Now know that this has a formula 1 minus phi a, which is equals to this probability. This. Now we will shift this 1 over there, or you can just write it like 1 minus 0.0082, which would be 0.9918. Now taking the inverse, you have to read this value from the table. So this is our table for normal distribution function, and our value was 0.9918. So how to find an inverse for this value? You have to first find the nearest value to that value, 0.9981, 0.18, and the nearest value, let's look for it somewhere. It would be somewhere here. It is. There's an exact value, which is rare, but in this case you have an exact value. So let's read the table. How to read the table? To read the value coinciding on this column on the Z column, which is 2.4, and read the heading of this column of the number, which is 0. So the answer would be 2.40. So from the table, the value of A is 0, not 0, 2.40. Now, what you're going to do is equate this value of A by this expression, 36, 36,800 minus the mean over standard deviation is equal to 2.40. Now, make mean the subject. Right? So this here is our first equation. Let's do the same procedure for this second equation as well. Now, again, the formula would be 1 minus pi A minus 0.6915 would be 0.3085. Don't forget to write this inverse thing here. Now let's move to the table. Now we have to look for the value of 0.3085. So let's see if there's any. Actually, as you can see, this table is starting from 0.5. That means this value is too small to be in this table. So when this case occurs, we subtract this value from 1. So we are going to subtract 0.3085 from 1, and that would give us again 0.6915. So we have to look for 0.69915. Let's see if there's a value near to it, 6915. Here it is, the exact value. And reading the table, 0.5. Okay. One thing to take notice of, since we subtracted it from 1 because we couldn't find this value in the table, the answer that we are going to write, which is 0.5, is going to be in negative. So negative 0.5, and equating now, 31,000 minus mean over standard deviation is equals to minus 0.5, and then making mean the subject again to make it easier for us to solve the equation later on. Plus 0.5 standard deviation. We have got our second equation. Now we just have to solve them simultaneously to get the answer. What we can do is just equate these, since both of them have the same subject of formula. So that would be 36,800 minus 2.4 is equals to 31,000 plus 0.5, and shifting it there, it would become 0.5 plus 2.4 is equals to 36,800 minus 31,000. Doing the calculation, you will get standard deviation is equals to 5,800 over 2.9, and finally the standard deviation is coming out to be 2,000. Now we have to find out the mean. Use any of the equation and substitute the value of standard deviation to find out mean. So let's just take the first equation, 36,800 minus 2.4 into 2,000. And this would give us an answer of 32,000. And these are the values of mean and standard deviation. The random variable x has the distribution where this is given and the mean is not equals to 0. Find this. Okay. So let's write it. What would be the formula? Phi A. But first we need to work with this. Let's make any of the subject. Let's make mean the subject. So it would become mean is equals to 3 standard deviation over 4. This is one way, but if we make standard deviation the subject, then it would be a smaller method. Which is going to be 4 mean over 3. Now let's write it in this form. 3 mean minus, we have to, yes, let's take this over. I'm going to use this. In the place of standard deviation, we're just going to write 4 mean over 3. Right. Now let's simplify it. This would be 3 mean minus mean. That would be 2 and 3 over 4. This would become then, this cancels out. Right, so this becomes 1.5. Now I simply have to find out the value. First, the formula is just phi 1.5. Let's read the value of 1.5. Remember, it's not an inverse, so the method is different. Here is 1.5. Since there's nothing more than 1.5, so the value would be just, there's a 0, so it would be just 0.9332. So from the table, 0.9332, and as always, give the answer to 3 significant figures. In Palmer Dawn, 22% of families own a dishwasher. Find the probability that of 15 families chosen at random from Palmer Dawn, between 4 and 6 inclusive, own a dishwasher. Between 4 and 6 inclusive. So the number is 15 families, and the success, or P, is equal to 22 over 100. That becomes 0.22. And failure, which is denoted by Q, becomes 1 minus 0.22, and that would be 0.78. We have to find out the probability of families of 4, 5, and 6. So let's just, the formula is NCR Q N minus R P R. These are the powers. This formula is given to you, so you just have to substitute and find out the answer. So let's write it. So N15 C R would be 4 firstly, and then Q, which is 0.78. 15 minus 4 is 11, and 0.22 is P, which is to the power 4, plus, then we have the probability of 5, so 15 C5 into 0.78 to the power of 10, and into 0.22 to the power of 5, Lastly, 15C6 into 0.78 to the power of 9 into 0.22 to the power of 6. Now doing the calculation, you will get an answer of 0.38398. And this is the answer. A random sample of 145 families of Palmerdon is chosen. Use a suitable approximation to find the probability that more than 26 families own a dishwasher. So whenever the phrase suitable approximation comes, you have to use continuity correction. So let's just write it. Use continuity correction to convert normal distribution to binomial distribution. Remember this. So we have to find out the probability of more than 26 families owning a dishwasher. So this would become, according to the continuity correction, since the sign is greater and there is no greater and equal to sign, so it would become 26.5 minus mean over standard deviation. Now what about mean and standard deviation? We have formulas for mean and standard deviation as mean, it is n into p, and for standard deviation there is a formula of under root and npq. So we have n, which is 145, we have p and q as these, so we can easily find out the mean and standard deviation. So this would become 145 into 0.22, and the answer would be 31.9. This is the mean, and for the standard deviation, 145 into 0.22 into 0.78, and this is coming out to be 24.882. Now substituting the values, x is greater than 26.5 minus 31.9 over 24.882, and the answer would be 1, actually minus 1, minus 1.08255. Now the formula for this is 1 minus 5, 1.08255. Actually, just write it to 3 decimal places, so that would be 1.083, and finding the value of 1.083, remember this is not, you are not finding an inverse, so you just have to read the table. So 1.083, 1.0 is here, 2, 8, where is, it should be this value, 0.8599, and 3, for 3 is this 7, so you have to add 7 to 0.8, 7 to 8599. So working on just this, we found out that this was the value 8599, and we have to add 0.0007 to it. This would become 0.8606. Now you can subtract it from 1, it would become 0.1394. But this is actually not the answer. Why? Because before there was a negative sign that we ignored here, but now we are going to bring it back in the game, and for this negative sign we have to subtract this answer from 1 again. So I did it double time to make you understand, but you don't have to do this. You can just write this answer as final answer, because it is going to be the answer if we subtract 0.1394 from 1, and you're going to get 0.8606 again, which would be 0.861. So I did this whole thing to make you understand that one time we are subtracting it from this formula 1, and the other time we're subtracting it due to this minus sign. Okay, moving on. Vehicles approaching a certain road junction from town A can either turn left, turn right, or go straight on. Over time, it has been noted that of the vehicles approaching this particular junction from town A, 55% turn left, 15% turn right, and 30% go straight on. Right, so it's quite a lot of information. The direction a vehicle takes at the junction is independent of any other vehicle that takes at any of the direction any other vehicle takes at the junction. Find the probability that of the next 3 vehicles approaching the junction from town A, one goes straight on and other 2 either both turn left or both turn right. Okay, there's quite a lot of stuff going on in this question. But first, to make things easier, let's draw a detailed tree diagram. So there are 3 options. First is going left. Second is going right. And third is going straight on. This is for, okay. So 55% for the left. So we can write 0.55. 15% for right, so 0.15. And 30 for straight on, so 0.30. So these are the probabilities, and you have to find out that next 3 vehicles approaching the junction from turn A, one goes straight on and other 2 either both turn left or both turn right. Let's make it very detailed. So I'm going to add more branches. Left, right, and straight. Left, right, straight. Left, right, straight. Left, right, straight. And again, actually you don't have to do all this stuff. You can do a more simpler way. Just read the question. It says that 1 goes straight on. So let's just forget about tree diagram and think of, okay, let's just say that firstly it goes straight, S denotes straight, and then left and left. We can take this first, then maybe, so these are the probabilities that can happen if one is going straight and the other 2 are either going left or either both of them are going right. So first could be straight and the second and third could be left, and then again same for the right ones, and then first one is left and second one is straight, and then last one is also left, and again for the right one in this way. And you can observe that the arrangement is also different for each of the choices, and we're actually considering them because whenever we draw a tree diagram, we always consider the arrangement as well. So now we are going to write out all the probabilities and then add them to get the answer. So this would be what? 0.3 into what was the probability of it was 0.55 into 0.55. For this, it is so this is a conditional probability question. So the formula for this would be the probability of going straight on all 3 times. So straight, 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 intersection, the probability of choosing the same direction. So same direction over probability of same direction. So conditional probability is the measure of the probability of an event occurring, given that another event has already occurred. So we are to find the probability of the cars going straight on when this has already occurred. Right? So let's do the calculations. There would be for straight on, it would just be 0.3, since the probability of going straight on was 0.3 into 0.3 into 0.3. Make sure you do this according to this intersection sign over same direction. It could either be all 3 cars going right, which was I think 0.15. All 3 cars go in the same direction, that is right. That would be 0.15 to the power 3 into all the 3 cars going left, so that would be 0.55 to the power 3 to 0.33 to the power 3. Oh, so there's a mistake here. It's not going to be multiplied. As I told you earlier, that different branches, they are added, and these would be 3 different branches, so they should be added, right? So make sure you don't make this mistake. Okay, so now calculation, and the answer would be 0.137. Find the number of different ways in which all 9 letters of the word "sweet" can be arranged in each of the following cases. So where is this number of letters is 9, and find out the number of different arrangements of these 9 letters with no restrictions. So that would just be, let's first see if there's any repetition of letters. So the letter M is 2 times in the word, so 2 M's, and E is also 2 times, 2 E, and all the other are only 1 times. So this part is just going to be 9 over the repetitions of A letters, 2 factorial. This one, and this was for the, since they are being repeated, the answer 90722. This is part arrangement ordered matters, so we are going to use permutations. Order matters. No vowel A, E, I are vowels is next to another vowel. Okay. Let's first write the word, which is mince meat. Now remove the vowels and write the word without those vowels. So I would be removed, E, and A. So we are going to write again M, N, C, M, T. Right now, since we need to put vowels away from each other, they should not be next to each other. So in how many ways we can put? We have 1, 2, 3, 4, 5, 6 spaces to put the vowels. So now how many vowels are there? There are 4 vowels. and we have 6 spaces to keep them. So 6 spaces for 4 vowels. Right, so this would become what? This is telling us that it is 6p4. We have got the arrangement for vowels. Now let's do the arrangement for consonants, and that would be just 5 factorial, obviously, since they are 5, 1, 2, 3, 4, 5, and they can interchange places. But we have to take care of one more thing, which is the repetition of M and the repetition of E. So the repetition of M is in the consonant, so we are going to divide 2 factorial by 5 factorial, and putting in for the vowels, we are going to divide 2 factorial again for this repeating E. Right, so just make sure to do the calculation stepwise. First, write out the word and then put consonants, and then think about how many spaces there are for each vowel, and then remember to divide by the repetitions, and this would give us an answer of 10800 ways. Five of the 9 letters of the word mincemeat are selected. This shows us combination. Find the number of possible selections which contain exactly 1 M and exactly 1 E. Okay, so in our selection of 5 words, 1 M and 1 E are fixed. Since these are fixed, then the other M and E are removed from the total number of letters. So how many letters are left? Removing these 4 letters, we have got only 5 letters left, which are total, right? Total. And since 1 M and 1 E are fixed, these are fixed, then we have only got to make 3 more selections, right? So 5C3, and that would be 10. Remember that whatever is fixed, you do not need to add that into calculations. Find the number of possible selections which contain at least 1 M and at least 1 E. So this word at least is making a difference in this part and that part. So now it could be either 1 M or 2 E's or 2 M or 1 E. Let's write all the possibilities. So firstly, it could be both the M's and both the E's. These are fixed, so remember that do not include them in calculation. Okay, more possibilities. Only 1 M and only 1 E. Another could be 2 M's and only 1 E. And just like that, 2 E's and only 1 M. So these are the combinations. Now let's write their calculations. Since in the first one we chose 2 M's, both the M's and both the E's, so we have only got 5 letters remaining, and we have only 1 more selection to make, since the total we wanted was 5, right? So from 5 we only have to make 1 selection, since these are 4. And from the second one we took 1 M and 1 E, and the other M and E are removed, so that means again 5 options. We have to take 3, since we have to make a total of 5 letters. And then from third we removed 1 E, again 5. We have to take 2 more, and same for the fourth one, which is 5C2. This gives us 5, this gives us 10, this gives us 10, this also gives us 10. So adding them all up would give us an answer of 35 selections. So that's it for this paper.